Hello dear friends, this is Sonigra, and today in the subject of elements of mechanical engineering we will discuss the first chapter, that is introduction. Previously we have discussed the elementary terms related to thermodynamics. We discussed about the thermodynamics basics. Now today we will discuss about the first law of thermodynamics, zeroth law of thermodynamics, and some basic details related to temperature, enthalpy, entropy, etc. The objectives for today's presentation are covered like this. The first objective is to understand the concept of temperature, specific heat capacity, internal energy, and enthalpy, and to discuss the statements of zeroth law and first law of thermodynamics with its applications in actual field. Now first, concept of temperature. What is temperature, where it is used, and what are the basics related to temperature. First, definition. It is defined as the degree of hotness or coldness with respect to the reference line is defined as the temperature. So it is a measure of hotness or coldness of any body, any element, any fluid, or anything. That is called as the temperature. The basis for validity of temperature measurement is zeroth law of thermodynamics. With the help of zeroth law of thermodynamics, this entity can be defined, it can be measured. The scale for temperature is based on the zeroth law of thermodynamics. The units of temperatures are Kelvin and Celsius, represented by degree capital K, and Celsius is to be represented by degree and capital C. And the relationship between Kelvin and Celsius is 0 degree centigrade is equal to 273 degree Kelvin. Centigrade and Celsius both are same unit. There is a linear relationship between Celsius and Kelvin as represented over here. To convert 10 degree centigrade into Kelvin, add 273 in 10, that is 10 degree centigrade is equal to 10 plus 273, that is 283 degree Kelvin. 100 degree centigrade is equal to 100 plus 273, that is 373 degree Kelvin. Or say minus 100 degree centigrade means minus 100 plus 273, so that is 173 degree Kelvin. Hence we can say the relationship between Kelvin and degree centigrade is 0 degree Kelvin means minus 273 degree centigrade, and this is absolute zero temperature. Practically it is not possible to achieve this temperature. It's a just theoretical temperature, that is 0 degree Kelvin. It is the temperature at which all molecular movement is zero, and this is the base or reference for temperature in SI unit, and the definition of this temperature leads towards the third law of thermodynamics. Now what is zeroth law of thermodynamics? Let me discuss first that. The statement for this is, it states that if two bodies are separately in thermal equilibrium with third body, then they must be in thermal equilibrium with each other. Say if two bodies A and B are in thermal equilibrium with each other, then another two bodies A and C are in thermal equilibrium with each other, then all three bodies A, B and C are in thermal equilibrium with each other. This is the pictorial representation of the zeroth law of thermodynamics. You can see here A and B both are in thermal equilibrium, B and C both are in thermal equilibrium. Hence we can say A and C are also in thermal equilibrium, or the temperature of A and temperature of C will also be same after some time. This is because objects in thermal equilibrium have same temperatures. This is Zeroth Law of Thermodynamics. The explanation: if two systems, say A and B, are in thermal equilibrium with a third system, say C, separately, that is A and C are in thermal equilibrium, B and C are in thermal equilibrium, then they are in thermal equilibrium with each other. Say TA is equal to TC, TB is equal to TC, then A and B will also be in thermal equilibrium, so TA is equal to TB. Now let me see the animation related to zeroth law of thermodynamics.
This video on thermodynamics part 4 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the parts till 3 before going ahead with part 4. So what is zeroth law of thermodynamics? Zeroth law states that two systems in thermal equilibrium with a third system separately are in thermal equilibrium with each other. So now you understand why I explained you what is thermal equilibrium. So now you know what is thermal equilibrium, right? Two systems will be in thermal equilibrium if both of them are at the same temperature, right? So zeroth law states that if I have two systems which are in thermal equilibrium with a third system, for example, if I have two systems A and B, such that A is in thermal equilibrium with a third system, let us say C, and B is also in thermal equilibrium with C. That means A and B are in thermal equilibrium with each other. So this was the statement of zeroth law. Let us understand it more carefully. Let us suppose I have two systems A and B. Let us suppose A and B are two systems which are not in thermal equilibrium. That is, these two systems are at some different temperature. Now let us suppose there is another system C with which these systems are in thermal equilibrium. That is, let us suppose A and C are in thermal equilibrium. Again, B and C are in thermal equilibrium. But A and B are not in thermal equilibrium. What does that mean? That means that A and B are also in thermal equilibrium. So what do we conclude? That if A is in thermal equilibrium with C, A is in thermal equilibrium with C, B is also in thermal equilibrium with C, that means that A is in thermal equilibrium with B. Now the most significance, or what is the significance of this zeroth law? The significance is that zeroth law suggested that there should be a physical quantity which should have the same value for systems in thermal equilibrium. Till now, I already defined what is thermal equilibrium to you, right? But it originated in this way. Zeroth law came up and zeroth law told this fact that if two systems are in thermal equilibrium with a third system, that means that these two systems are in thermal equilibrium with each other. So from zeroth law, it was suggested that there should be a physical quantity which should have the same value when two systems are in thermal equilibrium. So this physical quantity was defined as temperature. So temperature is the quantity which defines or which determines whether or not the system is in thermal equilibrium with the neighboring system. So from there we started defining thermal equilibrium as two systems at same temperature is in thermal equilibrium with each other. So basically the temperature, zeroth law gave birth to the significance of temperature in thermal equilibrium.
Now second video for the same zeroth law of thermodynamics, let me see that.
Thermodynamic variables. In this concept you study about zeroth law of thermodynamics, heat, work and internal energy. Zeroth Law of Thermodynamics. A diabatic wall. A diabatic wall does not allow exchange of energy between the system. Dithermic wall. Dithermic wall allows exchange of energy between the systems. Zeroth Law of Thermodynamics. Two systems, A and B, which are separately in thermal equilibrium with a third system C, are also in thermal equilibrium with each other. Concept of temperature from Zeroth Law of Thermodynamics. Temperature of a system or a body is a physical quantity which determines whether the system is in the thermal equilibrium with another system in its contact or not. Heat, work and internal energy. Heat. Energy is transferred between a system and its surroundings whenever there is temperature difference between the system and its surroundings is called heat. Sign conventions for heat. When energy is transferred to the system from its surroundings, then heat is taken as positive. When energy is transferred to the surroundings from the system, then heat is taken as negative. Derivation for work done. Work is said to be done if a body or a system moves through a certain distance in the direction of the applied force. Consider a cylinder fitted with a frictionless piston of area of cross-section A, figure. Let a gas be contained in the cylinder. The walls of the cylinder are perfectly conducting, one, so that the gas in the cylinder is in thermal equilibrium at temperature T with its surrounding. If P be the pressure of the gas on the cylinder, then the force exerted by the gas on the piston of the cylinder is given by F is equal to PA. Let the piston move through a small distance dx during the expansion of the gas. Therefore, the work done by the gas is given by dW is equal to F dx is equal to PA dx. Since AdX is equal to dV, change, increase in volume, dW is equal to pdV. If the volume of the gas increases from initial volume Vi to final volume Vf, then the total work by the system or gas can be calculated by integrating equation 1 between V is equal to Vi to V is equal to Vf. Integration of dW is equal to integration of pdV from Vi to Vf, or W is equal to P integration of dV from Vi to Vf, or W is equal to P into V from Vi to Vf is equal to P into Vf minus Vi.
Now second, that is specific heat. What do you mean by specific heat, where it is used, and what's the importance of specific heat in the field of thermodynamics? Let me see that. Before going in the detail of this terminology, let me take one experiment. Take 1 kilogram of water. Let me take 1 kilogram of water in our tank. Now, to increase the temperature of this water, some heat is required. Let me say certain heat is required to increase its temperature by 1 degree centigrade. So for example, present temperature is 28 degrees centigrade. Now the amount of heat required to increase its temperature from 28 to 29 degrees centigrade is certain entity, and that entity, that heat is defined as the specific heat of the water. And specific heat varies with respect to the entity. As the material changes, its specific heat changes. the specific heat of a substance is defined as, now let me define this term based on this experiment, the quantity of heat required to raise the temperature of a unit mass of the substance through a unit degree temperature difference. So in other words, the heat required to increase the temperature by 1 degree or unity of unit mass or 1 kilogram mass is defined as the specific heat capacity or specific heat of the body or material or any fluid. Liquids and solids have only one specific heat, which is represented by capital C, and the unit of specific heat is kilojoules per kilogram Kelvin. You can understand the units also, and based on this unit also we can define the specific heat capacity. Kilojoule is the unit of heat, so unit of heat per 1 kilogram of mass per 1 degree Kelvin. And gases have two specific heats. Say for example air, nitrogen, oxygen, carbon dioxide or acetylene, all the gases are having two types of specific heat. First is the specific heat at constant volume represented by Cv, and second is specific heat at constant pressure, it is represented by Cp. The specific heat at constant volume, the definition of Cv, how can we define it? It is the amount of heat required to raise the temperature of unit mass of gas by 1 degree at constant volume. What's the meaning of this term? Let me take unit volume of the gas, say for example 1 liter of gas, and the heat required to increase the temperature of gas by at constant volume by 1 degree is Cv. Similarly,